Determination of atomic number. Moseley's method. From the frequency of X-ray emitted, Moseley's shows that the frequency of a given line in a spectrum was connected with the atomic number by the expression nu equals to A into a square of in bracket z minus b, where nu is the frequency of radiation, z means capital Z, Z is the atomic number, and A and B are constant. For the first line, longest wavelength of the K spectrum, the constant A equals to 2.47 into 10 to the power 15 and B equals to 1. Nu, that is frequency, is determined experimentally, and Z can be calculated from the equation. And the second method, from scattering of alpha particles. Since atomic number is equal to the net positive charge on the nucleus, it can be determined by measuring the scattering of alpha particles produced by bombardment to the thin sheet of elements. Next, importance of atomic number. These are some importance or properties of atomic number. In the improvement of the periodic table, to explain the position of isotopes, to explain the anomalous pairs between argon and potassium, tellurium and iodine, cobalt and nickel, in the discovery of new element in the periodic table, and in the determination of structure of atom. Now the next talk is about neutron, represented by 0 n sub 0 sub 1 or 0n1. It was discovered here. Sub means subscript and sup means superscript. It was discovered by James Chadwick in 1932 by bombardment of alpha particle on beryllium atom. For example, Be sub 4 sup 9 plus He sub 2 sup 4 equals to n sub 0 sup 1 plus C sub 6 sup 12. Here B represents beryllium and He represents alpha particles, N represents neutron and C represents carbon. Or it may be written as BE 9BE. Its absolute and relative charge is 0. Its absolute mass is 1.6748 into 10 to the power minus 24 gram, or 1.6748 into 10 to the power minus 27 kg, but its relative mass is 1. That is mass of neutron. We are talking about neutron. It is also one of the fundamental particles present in the nucleus of all atoms except hydrogen. That is, hydrogen is not with neutron. Hydrogen only contains proton. It takes, that is neutron, takes part in nuclear reaction. The number of neutrons can be calculated with this formula: N equals to cap A minus cap Z. Here cap means capital, where N equals to number of neutrons, cap A equals to mass number or atomic mass or number of nucleons, and Z, cap Z, equals to atomic number. So atomic number is the number of protons or number of electrons for neutral atoms. Now let's talk about atomic mass, or also called mass number. Mass number is the sum of number of protons and neutrons in the nucleus. That is, mass number equals to number of protons plus number of neutrons, or cap A equals to cap Z plus N. Since each proton and each neutron has a mass approximately equal to 1, on the atomic weight scale, the atomic weight of an element is approximately equal to its mass number. If the mass number of element is cap X, if the mass number of an element X be cap A and its atomic number be cap Z, then the element can be represented by X sub Z sup A and neutron n equals to cap A minus cap Z, where n number of neutrons, A atomic mass number cap A, and cap Z numbers of protons or atomic numbers. Now we see some main elementary particles and their properties. So let's start one by one. First we see the discoverer. So electron was discovered by J.J. Thomson in 1897. Proton was discovered by Ernest Goldstein in 1886, and neutron was discovered by James Chadwick in 1932. And second experimental events, electron from cathode ray experiment, proton from positive ray analysis, and neutron from nuclear reactions. Now its symbol, the electron symbol is E or beta minus, beta sup minus, and proton symbol is H sub 1 sup 1 or P, or neutron symbol is N sub 0 sup 1 or simply N. Now the charge, about charge. So electronic charge is, that is charge of electron, minus 1.602 into 10 to the power minus 19 coulomb, and protonic charge is plus 1.60 into 10 to the power minus 19 coulomb, and neutron is chargeless, that is there is no charge on neutron. Now relative charge, electron is minus 1 and relative charge of proton is plus 1, and for neutron is 0. Now mass in AMU, atomic mass unit. Electron mass is 0.00054886, proton mass is 1.007825, and neutron mass is 1.008665. Now absolute mass, for electron 9.109 into 10 to the power minus 31 kg, and for proton 1.6725 into 10 to the power minus 27 kg, and mass of neutron 1.6748 into 10 to the power minus 27 kg. Relative mass for electron is 1 by 1837 equals equal to 0, and relative mass of proton is 1 and relative mass of neutron is 1. Now location where these elementary particles found. Electron is found outside the nucleus, proton is inside the nucleus, and neutron inside the nucleus. Stability, the electron is stable, proton is stable, and neutron is unstable due to neutron decay. And rest mass energy in mega electron volt, for electron it is 0.511, and for proton it is 938, and for neutron it is 940. So these are some important points related